SI units of resistance are is ohms. Then what are the SI units of specific resistance? Rho. SI units of specific resistance rho is ohm meter. So here ohm symbol is Greek letter. It is called Greek letter omega, and here ohm meter can be written as like this symbol, ohm meter. So listen, what is resistance? Resistance, it is a measure of opposition of the flow of current through an object. Okay. So this resistance is directly proportional to length, means length increases, resistance increases, and inversely proportional to cross section area. Cross section area means the area of the cross section of the wire. Okay, so by combining these two, we will write R is directly proportional to L by A. So if we want to remove this directly proportional symbol, we have to keep a constant, that is nothing but rho, specific resistance or resistivity. Specific resistance or resistivity. SI units of R resistance are ohm, and SI units of rho is ohm meter. Understand, Nana? So next definition is conductance. What is conductance? So this formula you remember, R is equals to rho into L by A. What is conductance? So conductance can be defined as the ability of a substance to allow electric current. It is the ability of a substance to allow the flow of current. So it is a reciprocal of conductance is the reciprocal of resistance. Conductance is another definition. Conductance is a reciprocal of resistance. What is the conductance symbol? Suppose the conductance symbol is G. It is a reciprocal of 1 by R. Reciprocal means 1 by R. So what is the formula of R? R formula is rho into L by A. So that formula we can write like this, rho into L by A. If we write this denominator value, so we will get A by rho into L, or we can write this one 1 by rho into A by L, 1 by rho into A by L, where 1 by rho can be written as kappa K into L by A, where kappa is a conductivity, or it can be called as specific conductance. So what is the units of conductance? Generally, it is the reciprocal of resistance, no? So what is the resistance units? Ohm, right? Ohm. So it can be written as mho or ohm units. But here In our chemistry, we have SI units of conductance. So, SI units of G, conductance, is Siemens. Okay, it is represented by capital S. It is represented by capital S. Now, what are the units of specific conductance rho? Specific conductance rho. So, specific conductance rho units are Siemens meter inverse. Siemens meter inverse. Okay, Siemens meter inverse. So, conductance is the ability of a substance to allow the flow of current. Okay, or it is also defined as it is the reciprocal of resistance. So, G is equals to 1 by R. So, 1 by R, instead of R we can write rho into L by A. So, if we rewrite the equation 1 by rho into L, so this A will come up because it will be reversed if the denominator comes up. Okay, so A by L. So SI units of conductance G is Siemens. So it is represented by capital letter S. Whereas conductivity or specific conductance kappa K has units. Specific conductivity kappa has units Siemens meter inverse. Siemens meter inverse. Now let us talk about which element conducts more electricity, or the element which have high conductance is silver. Silver is the good conductor of electricity. Silver is the good conductor of electricity, whereas some metals like iron, copper, okay, these are all having good conductors, and minerals have the good conductors, and aluminum is also a good conductor. That's why we are using as the wire, aluminum and copper. So silver conductivity is conductance is 6.2 into 10 power 3 Siemens. Specific conductance Siemens meter inverse. Silver is a good conductor, whereas pure water conducts a very poor current. Its value nearly 10 power minus 3 Siemens meter inverse, 0.2 something like that into 10 power minus 3 values. It means pure water is a bad conductor of electricity, whereas plastics and glasses, these are all poor conductors of electricity. So these are all poor conductors of electricity. Plastics and glass and some like polythenes, these are all poor conductors of electricity, including pure water. Pure water also bad conductor of electricity, but water having ions is act as the again good conductors of a good conductor. Okay, so what are electrical conductors? Conductors which are formed by solid materials like metals or metal oxides, or like ceramic substances. Okay, electrolytic conductors are the conductors which are formed by solute and solvent. Solute and solvent means they are electrolytes. They are electrolytes. That type of solutions which conduct electricity are called electrolytic conductors. Conductors which solutions which allow electricity are called electrolytic conductors. Electrolytic conductors, or we can call it they as electrolytes. We can call it a electrolyte. Now, electrical conductors are also called electronic conductors. Electronic conductors like chips, okay, wires, materials, okay, and diodes. These are all electrical conductors or electronic conductors. Electrical conductors or electronic conductors. Electrical conductors or electronic conductors. Okay, here electrolytic conductors are called electrolytic conductors or electrolytes. Electrolytes, solutions or liquid substances which allow or which pass the current are called electrolytic conductors, or simply we can call as electrolytes. Examples for these electrical conductors are metals, ceramic substances, or diodes, or semiconductors, or some metal oxides. These are all comes under electrical conductors, solid substances. Okay, electrolytic conductors nothing but like HCl, liquids, dilute HCl and dilute NaOH, dilute NaCl, or acidic substances solutions, or these are all substances which are having ions in the solution are called electrolytic conductors. Substances which are having ions in the solution are called electrolytic solutions. Examples: HCl, KCl, NaOH solution, KOH solution, CaOH negative solution, and NaCl solution, CaCl2 solution. These are all electrolytes. Now, these electrical conductors depends on. So, electricity flow through the electrical conductors depends on the nature and the structure of the material. Nature and structure of the metals. Okay, nature and structure of metals. And here the number of electrons also, the number of valence electrons in the metal, number of valence electrons in the metal per atom, okay, per atom also affects the conductivity, Next, temperature. So generally we know that temperature increases for the solid materials, temperature increases, electrical conductance decreases. So temperature increases, electrical conductance decreases. Okay. So electrical conductors conductivity depends on the nature and the structure of the metals. Okay, nature and structure of the metals, and the number of valence electrons per atom. Okay, number of valence electrons present in a per atom. So like 2, 3, aluminium plus 3, no, like that. So like that number of electrons increases, conductivity also increases. Next, temperature. Sometimes temperature increases, electrical conductance decreases. These are the factors which affecting or the electrical conductance which depends on these factors. Okay, nature and structure of metals, number of valence electrons, and temperature. Okay, similarly, electrolytic conductance is also depends on the some factors of the solution, some factors of the electrolytes. What are they? See here also, nature of solute means whether it is ionic or non-ionic. So like NaCl ionic, KCl ionic, NaOH ionic. But whereas sugar molecules non-ionic, so they will not conduct electricity, like that. Okay, nature of solute. Next, the nature of solvent and its viscosity. The nature of solvent and its viscosity. Nature of solvent and its viscosity. So if the viscosity is more, then the conductivity will be less, because the movement of ions will be less in the more viscous solutions. Movement of the ions will be less, so that conductivity decreases, like that. Nature of the solvent means solvents also polar. we have two types of solvents, no, polar solvents and non-polar solvents. Like that, here also, if the solvent is polar, then the conductivity will be more. If the solvent is non-polar, then conductivity will be decreases. Next, concentration of the electrolytes. Next, concentration of electrolyte. So, concentration increases, the number of ions in the solution increases. The number of ions in the solution increases. So, due to this reason, conductivity increases. Concentration of the electrolyte increases, number of ions in the solution increases. That's why conductivity increases. If you are using high concentration also, sometimes due to the lack of movement or undissociation, so sometimes high concentration solvents also, so liquids also does not conduct electricity. Next, nature of size of the ions. Next, the size of ions in the solute. Next, size of the ions in the solute. Size of the ions in the solution simply, because ions are formed in the size of ions in the solution, because when we add solute, then only we will get when we add solute to the solvent, then only we will get ions. So that we have to write in the solution. Okay. So size of the ion increases. So maybe the ability to flow. Based on that, we can say whether the conductivity increase or decrease. Next, temperature. Generally, temperature increases. Here, in this case, in the case of electrolytes, temperature increases, conductiviटी also increases due to the kinetic energy of the ions increases, so that the current carrying power of the ion also increases. Temperature increases, kinetic energy of the ion increases, so that's why the movement of the ions increases, so that they can carry current or charge of the current. Okay, so that's why here temperature increases, conductance increases, conductance increases. Okay, this is about electrical conductors and electrolytic conductors. What are electrical conductors? The solid material substances which conduct electricity are called electrical conductors, or we can call them as electronic conductors. Electronic conductors, like we use in wires or in computer motherboard, some materials like chips, diodes, transistors. These are all comes under electrical conductors. Ceramics, metal oxides, these are all. Okay, electrolytic conductors means the solutions which conduct electricity, because of having ions, they are called electrolytic conductors. Electrolytic conductors are also called electrolytes. Okay, electrolytes example: HCl, dilute HCl, dilute NaOH, dilute H2SO4, dilute NaCl solution, and dilute CaCl2 solutions. Whatever it may be, the solution having ions, oppositely charged ions, or the polarity, they conduct electricity. Such type of solutions are called electrolytic conductance. Such type of conductance is called electrolytic conductance. Here, electrolytic conductance depends on the nature of solute, whether it is maybe ionic or neutral. If the neutral, no ions formation, so no conductivity. So nature of the solvent and its viscosity. So if the solvent is a polar, then conductivity will be increases and viscosity should be less. Then only ions can move freely. If the viscosity is more, ions can't move freely. Next, concentration increases, number of ions increases, so that conductivity increases. Here, the size of ions increases in the solution, then conductivity also increases or decreases, depends upon the ability or solvation. Okay, temperature. Solvation means the ability of ions to dissolve in the solution. Okay, temperature. Next, temperature increases. What happened? Conductance also increases in the electrolyte. Whereas in the electrical conductor, nature and the structure of metals depends on the electrical conductance. So if you see that heaters or filaments makes like spring, because that structure gives more resistance. Okay, spring like structure gives more resistance, that's why that structure also affects. Okay, next, solid substances nature means good metal conductors, semiconductors, insulators are there, no, like that. That nature is called here nature and of metal. The number of electrons present per atom, so valence electrons here we have to consider. The temperature increases, the generally in metals temperature increases, so conductivity decreases. So these are the differences of electrical conductors and electrolytic conductors. In the examination, they may ask you the question like this: what are the factors affecting, or what are in what factors electrical conductors depends? Like that, they may ask, or what are the factors affecting electrolytic conductance? Okay, these are the very important questions which can be posed in the public examination. Okay, so I am recalling once again what we discussed, and here one point I remember to discuss with you: superconductivity. Conductivity. Superconductivity can be defined as. So the conductivity, infinite conductance of a material, the infinite conductance, superconductivity have zero resistivity. Superconductors have zero resistivity. Superconductors. Okay. So conductors which have zero resistivity or infinite conductivity. Conductors which have zero conductivity or infinite conductivity, zero resistivity or infinite conductivity are called superconductors. Conductors which have zero resistivity or infinite conductivity, are called superconductors. Means they allow complete all current without resistance or without loss of current. Okay, so such type of conductors are called superconductors. In the early days, they considered only metals at very low temperature like 0 to 50 kelvin. They conduct electricity. They consider like this. So the low temperature act as superconductors. But nowadays, some materials like ceramics or metal oxide like cuprous oxide, okay, conducts electricity at high temperature also, nearly at 150 kelvins. Nearly at 150 kelvin. Some ceramics and metal oxides conducts at very high temperature also, nearly 150 kelvins. So ceramics and metal oxides conducts electricity at very high temperature, 150 kelvins are nowadays discovered. But in the earlier days, only scientists considered that only metals at very low temperature, only metals, not other elements, only metals can act as the superconductors, they thought. But metals, not only metals, ceramic substances and metal oxides also act as the superconductors. These superconductors are highly useful to transfer the electricity without loss. Okay. Okay. Now I am recalling once again what are the topics we discussed. First one we discussed resistance, right? So what is the resistance? We already discussed that resistance is the opposition of conductance or the flow of current. Okay, R is directly proportional to L, R is inversely proportional to 1 by A. So from this we wrote already R is directly proportional to L by A. From this we wrote R is equals to rho into L by A, where rho is called resistivity. Resistivity already completed now, or it is also called specific resistance. This specific resistance will have different for different materials. Specific resistance is different for different materials. So what are the R units? Resistance units what? Ohm. It's represented by the Greek letter omega. Okay. So what are the units of resistivity? Rho. This is pronounced as rho. Okay. So what is the units? Ohm meter. Okay. Similarly, we discussed about conductivity. So conductance. What is the conductance? Conductance is the reciprocal of G is reciprocal of resistance R. So from this we wrote G is equals to R means what? Rho into L by A. So we wrote 1 by rho, because R is in the down mode, so the denominator comes up. So 1 by rho into A by L. 1 by rho into A by L. So 1 by rho here can be written as G is equals to K kappa A by L. Here this K kappa is called conductivity. So what is the conductance units? Siemen. Conductance units what? Siemen. What are the conductivity units? Siemen meter inverse. Okay. So kappa units. So what is the conductivity definition? Conductivity can be defined as the conductance of a substance having unit cross section area and a unit length. So A by L value becomes 1, then the conductance is called conductivity. Similarly, we can define resistivity. So R rho. So L by A. If 1, then resistance of the substance is called resistivity. Okay, these are all definitions we discussed. Okay, so if you have any doubts, you can ask me.